Welcome back to Unit 5. This is Lesson 2. We're talking about similar figures. Now, similar kind of plays off nicely from what we did last unit, which was congruent figures. Similar has a symbol, and it's just like the top part of the congruent sign above the equals. It's just that little squiggly. I have no idea what that technically is called. You guys probably do. That's the symbol for similar. Now, if two figures are similar, they have the same shape, but they are not necessarily the same size. So you'll have like little triangle, big triangle. Okay, they're the same shape of triangle, but different sizes. Okay, now there's two qualities to similar figures in particular. So we'll compare this to what we did last unit again, where we did congruent, but basically we're talking about the sides and the angles of the two shapes. Corresponding angles, or angles that go together in the two shapes, they are congruent. And these are like the two big things you need to take note of today. If two shapes are similar, two polygons are similar, their corresponding angles are congruent. That's the same as what it was last unit. It's their sides that are different. Obviously, corresponding sides are not the exact same length. Their sides are not congruent. Their sides are proportional. So here we go again with like what we did in lesson 1. This is the difference between this unit and unit 4, congruent figures. Okay, so take note of that. That is the difference between polygon congruence and polygon similarity. The sides aren't congruent, the sides are proportional. Okay, so let's kind of like put that all into practice. Example 1 here, little triangle, big triangle. And they're telling me that these two triangles are similar. This is called a similarity statement. Last unit, it was called a congruent statement. So this like plays off very nicely from what we're fresh off of working with. So this is triangle DGF is similar to triangle HMK. Find each of the missing angles and sides. Now, the angles should be equal to one another, the angles that go together. And guys, the order of the letters tells you what goes together, just like it did last unit. So angle M, that's the middle letter, that should go with angle G in this little triangle. If G is 70, M is 70. Angles, you do not have to think that hard on because they're congruent. So if angle K, that's the last letter, that should go with angle F. Ooh, I don't know angle F, but I could figure it out. There's 180 in a triangle. So if I just subtract off 60 and 70, ooh, a little sticky. If F is 50, K is 50, since those are corresponding angles here. Don't think that's hard with angles. Okay, corresponding angles are exactly the same. It's obviously the sides that are going to be a little bit tricky. They're proportional. So to figure out a missing side, I mean, think about it. You need to set up a proportion. So here's how you do that. You have to first find what's called the similarity ratio. I know this stuff can get like a little deep here. There's a lot going on, I'm not going to lie. The similarity ratio we talked about in lesson 1, that's just a fraction. And that's going to be a fraction that tells you how the sides relate to one another. So let me just look at my triangles here. It's kind of like the alien picture from the first set of notes. I see like this bottom side. These two sides are corresponding, and I have both of the measurements. So I can use that pair of sides to show how the sides relate in a ratio. So 6 meters on the little one is 9 meters on the big one. So I'm going to write a ratio, 6 over 9, and I'm going to reduce it. I'm going to divide both of those by 3. This is what's called my similarity ratio. For every 2 meters on the little triangle, that's 3 meters on the big triangle. So that's how the sides relate, my similarity ratio. I'm going to use that ratio and set up a proportion to find these missing side lengths. Okay, this is how the sides should relate. 2 on the little should be 3 on the big. So I'm going to compare that to like what's happening with the corresponding pair that I'm trying to find a missing segment on. So if I'm trying to find HM, where is that guy? HM is right here. That corresponds with DG. Okay, I went small over big. So remember we talked about being consistent. Small over big here. So the small triangle, it's 5. I don't know how big HM is. Ooh. So I'm going to put that on bottom. And then once I have it, I just cross multiply and divide. So 3 times 5 divided by 2. 7.5 would be how big HM is. I get it. This is kind of a lot. Putting you on the spot though, can you find GF? Let's find out. Okay, on example 2, so this one they told me the shapes were similar. On example 2, they're asking me if they're similar. So same concepts, but kind of a different way to approach it. That's what I got to figure out first. To answer the first part, so kind of take note of this here. To answer the first part, I have to think about 2 things. And they're the 2 things that we talked about at the very beginning, okay? I have to figure out if corresponding angles are congruent. And then I have to check the sides to see if the sides are proportional. All those things have to be true for me to say, yes, these are similar. Okay, so check the angles first. That's way easier to see. So get that out of the way. Okay, what do I notice? I notice that A and F both have 1 congruent mark. B and E have 2 congruent marks. And then C and D have 3 congruent marks. So I notice that there's 3 pairs of congruent angles. So corresponding angles are congruent. So that part's good to go. Now I need to check to make sure the sides are proportional, which is going to be a little bit more work, but I can do this. To do that, I'm going to check the ratios. So I'm going to take side lengths that correspond and write a fraction and just see if I get the same fraction every time. That tells me that they're in proportion with one another. So check it out. AC. So that's the side between 1 mark and 3 marks. That's going to go with DF over here between 1 mark and 3 marks. So I'm going to make a ratio out of those corresponding sides. 18 over 24. I need to reduce that. I'm lazy. I type it in as a fraction. 3/4. Okay. That's how that pair of sides relates. 3 over here is 4 over here, whatever the measurement is, inches, meters, whatever. All of the corresponding side lengths need to be in that ratio for me to say, yes, they're proportional. So 15, ooh, be careful, I would have messed that up. 15 actually goes with 20. And here's why. 15 is the side between the 1 mark and the 2 mark. That's 20 over here, 1 mark and 2 mark. Don't screw that up. Use your marks to tell you what goes together. So does 15 over 20 reduce to 3/4? It sure does. Okay, my last pair is going to be 12 and 16. And that reduces to be 3/4. So if all 3 pairs of your corresponding sides reduce to be the same ratio, that means they're all in proportion to one another. Every 3 inches on this figure is 4 inches on this figure. Okay, whew, these are similar. So I'm going to write a similarity statement. The similarity ratio, guys, is just 3/4. You can write that a few different ways. It's just the fraction that I got every single time. The statement, I'm going to say like triangle ABC, watch your order, is similar to triangle. I went 1, 2, 3 marks, so FED. Wasn't that fun? Okay, on the back, it's not nearly as bad. That's bad, I'm not going to lie. This is a little bit better. They're telling me these figures are similar. I got to find 3 missing sides. If you're finding a missing side in similar figures, you set up a proportion. There are honestly so many ways to set these up. I'm just going to show you what I do. So what I do is I look for a pair of corresponding sides where I'm given both of the numbers. So what do I notice? I notice that, ooh, the top. I don't know why that was so hard for me to see. I've got 5 on the little one, 10 on the big one. So I'm going to take those two sides, make a ratio out of it. Honestly, I'm going to be lazy. If I'm just writing a proportion to find a missing side, I don't even have to reduce that. I can, like the way these sides are related, just half. Basically, this one's twice as big as this one. So for every like 1 foot on here, it's 2 feet on here. But if I'm just after finding a missing side, I don't even have to reduce that. So I just go 5 over 10, and I'm trying to find x. So x is right here. It corresponds with this side. So be consistent. I went little figure over big figure. So I'm going to come back to the little guy and do little over big. Okay, so watch. I went 5 over 10 equals 10 over x. You could go 5 over 10 equals 10 over x over 10 equals 10 over 5. There's honestly more ways to set it up right than wrong, in my opinion. But I go 5 over 10, 10 over x. And then you just cross multiply and divide. So 10 times 10 divided by 5, x is 20. Same thing for y. I'm going to go 5 over 10 equals y over 35. Little over big, little over big. And then I just cross multiply and divide. Decimals are okay. I get 17.5. See what you guys get for z. Do the same thing. I'm going to end it with example 4 here. So you've got your car. You want to make a scale model of your car. That's a nice car. So basically the ratio of the actual car to the model is 12 to 1. So my car is like 12 times the size of the little model here. Now, my car measures 13.5 feet in length. So let's kind of get this visual on the figure here. So the car measures 13.5 feet in length and 6.2 feet in width. Over here, I want to find the dimensions. Take note of that. Dimensions means length and width of the model. So a lot of you probably wouldn't even need to set up a proportion for this, but know that just like I mentioned last lesson, if you're like comparing two different things, two different measurements, you can set up proportions to figure these out. If you can just punch in your calculator, go for it. But I know, here's the scale. The ratio of the actual car. So the actual car is 12. The model is 1. So basically the model is 12 times smaller. You could just divide by 12, but let me show you how to do a proportion. And you'd have to set one up for the length and the width. Okay, so I'm going to take the scale 12 to 1. They mentioned the actual car first. So the 12 is the actual car. The 1 is the model. So car, model, be consistent. Compare that to what you actually know about the length. You know the car, so put that on top, is 13.5 feet. I do not know the length of the model. Same thing over here. It's 12 to 1 for the width. All the dimensions are 12 to 1. I know the width of the car is 6.2. I don't know, we'll call it y, the width of the model. So I'd put that y on bottom. Okay, then I just have to cross multiply and divide for both of them. So really it's just dividing by 12, but we'll take it slow. Divided by 12. So the length of the model is 1.125 feet. And the width of the model is 0.5, we'll just say 0.52 feet. Okay, that's similar figures.